Lesson number 7 about solar energy, solar charger controllers. During this lesson, I'm going to explain two different types of solar charger controllers, the MPPT and pulse width modulation PWM controllers. In general, controller used to control current in and out of battery. So here we can see this is the controller. Okay, solar charger controller. And here we have the solar panel, the battery, and the electrical load. For example, the current comes from the solar panel to the charger controller. Then the charger controller will direct this current to the battery to recharge the battery. And at the same time, the charger controller can take the current from the battery and direct it to the electrical load. So the first point, control current in and out of battery. The next point, protects battery from overcharging. So this is a real problem when the battery direct connect to the solar panel. So if we connect the battery directly to the solar panel, when the battery is full charge, okay, let's say this battery now is start charging, and when the battery is full charge, the solar panel, if it's direct connect to the battery without a solar charger, then the battery will damage because of the overcharging. So the solar charger controller control this process, and when the battery is full charge, let's say now the battery is full charge, okay, so the solar charger controller will prevent the current from passing to the battery. The next point, regulate the voltage entering the battery. So also control the amount of the voltage. For example, we use a 12-volt battery. If we use a 12-volt battery, 12 volt, so the charger controller, maybe the solar panel provide more than 12 volt, for example 17 volt. The charger controller can regulate this voltage and select good voltage to recharge the battery, for example 14.5, for example, just an example. So this is another advantage of solar controller, is to regulate the voltage entering the battery. I'm going to explain these points in more details in the next slides. The next point, protect battery from over discharging. So over discharging, this means the battery will be, or the battery is empty. So now let's say the battery is empty. Okay, so the solar charger controller protect the battery from this situation, prevent the battery from over discharging. So maybe it let the battery at this level. This is just an level to understand the meaning of the over discharging. The next point, it contains sensors to protect battery from high temperature, so increase lifetime of battery. Two different technologies, pulse width modulation PWM and MPPT maximum power point tracking, are two different types of charging methods solar charger controllers can use to charge batteries from a solar panel. Both technologies are widely used in the off-grid solar industry and are both great options for efficiently charging your batteries. This point is very important point. Most 12-volt panels put out about 16 to 20 volts. So for example, we have these four panels, and these four panels are connected on parallel because the negative part is connected to the negative and the positive are connected to the positive terminals of the other panels. We can see the V open circuit, VOC, or V voltage for the open circuit, for each panel is about 17 volt. And we can see our battery need a 12 volt. So this is a very useful technology or method to charging the battery, because if the panels produce 12 volt, just let's say for example the panels produce just a 12 volt for a perfect conditions, okay, so we can get just 12 volt at a cold weather with a shiny sun. So to solve this problem, we make the panels work with 17, for example, between 16 to 20 volts. So let's say these panels work on the open circuit. It's about 17 volt. This is a very useful method when we have a cloudy weather or there is a fog in the weather, so we can still get voltages to charge the battery. You can see here most 12 volt panels put out 16 to 20 volts. So if there is no regulation, the battery will be damaged. Okay, so this is the benefit of the charger controller, because we use a panels of 17 volts. If there is no battery, if there is no charger controller and the panels are direct connect to the battery, then the battery may be or the battery will damaged from overcharging. Most batteries need around 14 to 14.5 volts to get fully charged. We can see this battery is 12 volt, but to be fully charged is need about 14 to 14.5 volt to be fully charged. So here's the question: why aren't panels just made up to 12 volt instead of 17 volt? So you can see the panels are made of 17 volt, but we need just 12 volt to recharge the battery. The solution is, if the panels provide only 12 volts, they will work only under, we can see, perfect conditions. So what are the perfect conditions? The perfect conditions are achieved at a cool, sunny weather. The panels need to provide some extra voltage so that when the sun is low in the sky, or you have heavy haze or cloud cover or high temperatures, so that the system will still produce some output from the panels. So for example, if these panels are just 12 volt, okay, just 12 volt, so we will enable to charge the batteries. We can charge the battery at the perfect conditions when we have cool sunny weather, but most of the days of the year there is no perfect conditions. So for this reason we have to increase the or choose a panels with a voltage more than the voltage of the battery, at least 17, or let's say 14 or 14.4 14.5 volts. A fully charged is 12 volt. So when the battery is a fully charged and we measure the voltage of this battery, let's say we use a multimeter or voltmeter, so we measure the negative terminal and the positive terminal, we see the voltage, it's about 12.7 volt. This on condition that the battery is not charging, so it's fully charged. But if the battery is under charging conditions, okay, so it's still connected to the panels, so the battery is under charging conditions, and we measure the voltage of this battery, we can see the voltage is about 13.6 to 14.4. So the panel has to put out at least that much under worst case conditions. To prevent the excess voltage, so what is the meaning of excess voltage? Excess voltage, for example, these series batteries, we have these two batteries on series, each battery is 12 volt. When we connect batteries on series, so the total will be added, so the total of these two batteries is 24 volt. This system produce 24 volts, and these batteries need about 24 volt to be recharged. We have two solar panels, each one produces 17 volt, and these two solar panels are connected on series. So the total voltage will be 17 plus 17, and it's equal 34 volt. 34 volts is larger than 24 volts. So if we connect the solar panels directly to the batteries, here we have a problem. We have the excess voltage problem, and the batteries may be damaged. How to solve this problem? We can see solar charger controller regulates the flow of energy. What this basically means is that the controller constantly checks the voltage and increase or decrease the current depending on the level of the battery. So the solar charger controller will solve this problem. The two different types of battery charger controllers are MPPT and PWM. MPPT stands for Maximum Power Point Tracking, and PWM stands for Pulse Width Modulation. So the pulse width modulation controllers are cheaper than MPPT. It create larger power losses. Up to 60% of power can be lost. So this is very high loss value, 60%. Okay, but so this is because PWM controllers do not optimize voltage going to the batteries, and as we can see in the next lesson how the MPPT optimize the voltage going to the battery. So this type do not optimize the voltage going to the batteries. This limitation makes a PWM controller a poor choice for large systems. Okay, so this is very important point. The PWM cannot use with large systems. So if we have a large system, we use the second type, the MPPT. And if our system is just a small system for a small house, we can use the PWM charger because this one is cheaper than, okay, the PWM is cheaper than the MPPT. However, in a smaller system, their low price make them available option. So we can select this option, the second option, the PWM, for a small system because they are cheap. Thank you.